Hi guys, and welcome to this video tutorial of Autodesk Inventor 2018. Today I'll be showing you how to 3D model an elliptical rudder. The reason why I'm doing this is because I am aware that many of you are working on aircraft engines, rotary engines, so you would like to add a propeller into your assembly. So I've chosen a rudder though, simply because the planform has a simpler shape to follow, so still it follows the same principle. So if you're able to follow this tutorial, you should be able to apply this principle when you model your propeller. So I'm going to start by creating a 2D sketch on my XY plane, and now I'm going to click on my parameters, and where it says user parameters, I'm going to say add numeric, so span, which is going to be 50. So your span will be the overall length of your rudder or propeller or whatever lifting surface you're generating. I'm going to type chord 0, which will be the length of the cross-sectional area at the root. I'm going to add another one, chord 1, chord 2, chord 3, and so on. I'll go up to 7. Okay, so we've got this. I'm going to click on my chord 0. I will leave it I will make it probably, actually I'll leave it like this for now. We'll get there. Now if you scroll down circle, you'll find your ellipse. So I'm going to place it at the center. It's going to be vertical, and now we'll dimension it. So my height will be, if you click on this arrow, you can go on your list parameters, and you will be able to see all the parameters that we've just created. It's going to be my span, and now I'm going to create a couple of construction lines. So click on construction, and it's going to go from the top to the center, and from the center to this edge. There we go. So they are both fixed. Now both constrained, and now what I will do, I will use trim. So I'll type X and then trim all of this. Okay, so I'm still waiting for another dimension. So I'll select this line, and what I will do, I will make it 10. Actually, I'll make it 5. And now I'll probably add another parameter. So just here where I have my chord, I'll call it chord and make it 10 divided by 2. Okay. So now if I click on it and scroll down my parameters, list parameters. So I have my chord parameter. So x is 5. And now I'm going to add the same dimension again. And click on accept. So this will generate a driven dimension. Should have generated it in the other side, so doesn't matter. I will do it again. There we go. Okay, and now I'm going to draw a line across my planform, and I will give it a dimension from the origin, and I'll make that dimension span divided by 5. Now I'm going to offset this line. So again, span divided by 5. Again, span divided by 5. Again, span divided by 5. If I go span divided by 5, it will go right to the top, so I'm going to say span divided by 10. And I'll offset it maybe just 4 mil. And now this one is going to be offset 0.99. Shouldn't be there. Offset it as 1, so I'll say 0.98. See what happens if I try again. There we go, that's fine, that's exactly what I was after. So now I can use the trim command. I'm going to type X. I'll start trimming off all of these lines. Go to the other side. Okay, so we're getting there. Next thing I'm going to do, I'm going to dimension all of these lines. Again, it will tell me that it will over constrain the sketch. Just click on accept, because we want driven dimensions, so they're adaptive and they will be following our parameters. So just generate all of these driven dimensions on all of the sections that we've generated. Okay, so we've got them now. Now if I open up my parameters again, you should be able to see all of these driven dimensions as reference parameters. So D3 is your chord 0, D11 is your chord 1, and so on. So my chord 0 is going to be D3 times 2. So it needs to be double. Just bear in mind we have half a section here, so it needs to be double. And then chord 1 goes from D11 onwards, D11 up to D17. So chord 1 is going to be D11 times 2. I'll just copy and paste this. And it's going to be 12. 13. 15. It would be lovely if Inventor had a function similar to Excel. This would be so much quicker. And then this will be D17. Okay. So let's see if this actually works. If I change my span, all of these dimensions should now update. So if I make it 100, there we go, they all update. All of my sections go wherever they should be, because we gave them an equation, so which was span divided by 5, I believe, correct, if I remember correctly. Now if I change my chord, let's see what happens. If I make my chord 20, there we go. If I make it double, yep, all of my sections adapt. So that is really good. That's exactly what we're after. So I'll bring back my original dimensions and just test. Just to check whether I got my parameters right. And I'll click on done. Okay, so our sketch is now ready. Now click on finish sketch. I will start another sketch on the same plane. I'm going to use project geometry, and I'm going to project everything Now I'll go on mirror. I will select all of my objects, and then where it says mirror line, I'll select my structure line and click on apply. Now we'll select the first half that first is selected and delete all of my reference, all of my projected geometry. Simply because I don't want them to interfere. I should actually be more careful so I don't remove all the constraints. All I'm doing is just deleting the projections. Okay, and now I'll give it another dimension. Again, this will be my chord, and the rest is done. Okay, so that's perfect. So now if I go and finish sketch, now if I turn off my sketch tool, that's it. So that's my sketch one. If I turn it on now, turn off my sketch one. So I can see that I have two different sketches for my planform. You may be wondering, why are you doing two sketches and not a single one? It is simply because we need two independent rails. You will see why after. Okay. Let's do another quick test. If I now change my bottom chord, if I make it 20, yeah, it does update. So that means that it's still symmetric, so it's perfect. That's what I wanted to check. And now I can start placing my sections and generating my skeleton. Before I do that, I will have to generate planes. So I'm going to go where it says work plane and say parallel to plane through point. I'm going to expand my origin. I'm going to select my exit plane. Say through here. I'm going to do the same. Select my exit to this point. Again, exit to this point. Again, exit to this point. Again, exit to this point. Exit this. And now I'm going to generate a point right at the top. And it may also be worth generating a plane that goes across the top. It may be useful, so I will create it. It's really close to our workplane 7 that you can't even tell. Our workplane 7 goes through here, workplane 8 goes through our point. Okay, so set these. We can start placing our sections. So to do that, I will use NACA foils. I don't know if you've heard of them before. They're basically off-the-shelf NACA sections. Foil sections. The reason why I would use this is simply because if you try to generate your own foil section, it will be quite hard to estimate what performance in terms of lift and drag you will be getting out of it. So, whereas with these NACA airfoils, there is a lot of empirical data out there because they have been tested again and again and again. So you can see you have your empirical data and all the graphs that you need in order to make a more reasonable prediction of what you're going to get out of your lifting surface in terms of lift and drag. In order to generate our airfoil, again, just so you know, these foils are the ones that normally go on all sorts of application, like ship rudders, sailboat rudders, aircraft rudders, aircraft wings, hydrofoils, Formula One, ailerons, etc. Turbine blades, all sorts of applications. So here we've got an equation. So what I've just done, I've copied the equation and I've rewritten it in a way that Inventor can understand it. So the way the equation works, you give x a value, and then Inventor will calculate the y coordinate at each value and will generate a curve for your profile. So the first part of the equation where it says t will be your thickness. So normally these foils, the thickness is given as a percentage of your chord length. So an AGA 0012 will be 12% of your chord length. The chord length is the length of your foil section, so it will go from here all the way to here. So 0.12 times your chord, that means that the maximum thickness of the foil, so let's say from here to here, will be 12% of the chord length. So saying that, I'm going to, after I've written this equation in a way the Inventor can understand it, I have to substitute this value. So my t is going to be 0.12 times my chord, and then my x is going to be x divided by my chord. So the section generated will be to the right scale, will be proportional. And then here I've just written my equation for chord 0. So as you can see, I've substituted my thickness here with the chord at the root, then x divided by chord 0, x divided by chord 0, x divided by chord 0, x by chord 0. And I've done the same for all of them. So there is one equation for chord 1, for chord 2, chord 3, chord 4, 5. I need one for chord 6. Just realize I skipped that. So I'm just going to rewrite these values. 6, chord 6, chord 6. Okay, so I've got this now. Now I will copy my equation. You can see, if I go on Inventor, I'm going to place my chord at the root. Sorry, my section at the root. So I'm going to start a sketch on the XZ plane. I'm going to work isometric. So I'm not really drawing, I'm just pasting my sections. And now under line there is an option called equation curve. So if I click on equation curve, then careful with this, and instead of using parametric we're going to use explicit. So click on explicit, and now here I will paste my equation, and x min is going to be 0 X max is going to be my chord. So I'm going to type chord and it will reference the parameter. And now I'm going to press enter. Oops. I was using chord 0 instead of, I typed in chord instead of chord 0. There we go. So it was my chord 0. Now if I click on OK, now as you can see I've got the perfect chord that I needed. I'm going to right click, delete my coincident constraint so I can freely move it around. And now I have to create the other half. So I'm going to create another equation curve. But this time I'm going to enter a minus at the beginning. So I will generate my curve on the minus y-axis. So I typed in a minus, pasted the equation, and now my x max is going to be again chord 0. And accept. And as you can see, it pasted my fault. I'm going to select it, right click, delete the coincident constraint, so it deletes the constraint to the center, drag it away, okay. And now I will constrain them together first before I place them. So I'm going to say I want a coincident between there and then another coincident between there and there. Okay, so now that my profile is constrained, I'm going to give it a coincident to the leading edge. Oops, it's not working because I need to project my geometry first. Okay, so now I should be able to do it. I will go on my coincident constraint, and I will constrain it from there to there. And now we'll give it a horizontal constraint from there to the origin. There we go. So now my file section is fully constrained. Perfect. So now if I hit finish sketch, now I'm going to follow the same procedure on the next plane. Again, I'm going to work isometric. I'm going to first project my geometry. Now we'll go to my notepad, copy the next equation for chord 1. Now equation curve again, paste the equation, and C max is going to be chord 1. As you can see, it's generating the chord in there. I'm going to do the same, type a minus, paste the equation, and x max is going to be chord 1. Perfect. Enter. I'm going to select both, one of them, right click, delete coincident constraint, second one, delete coincident constraint. I'll pull them away. I'll constrain them now. And a horizontal from there to the origin. Perfect. Now I'm going to finish my sketch. I'm going to be repeating the same step one by one, so feel free to skip the video forward if you wish. Equation curve, Actually, you can pull it away. I think it only adds the constant constraint after you place both of them, so it may save you some time if you pull it away directly. Port max, port 2, enter. Let's go for the third one. Oh, I know why. I know the reason why it's adding that constant constraint. It is because if you reference this geometry first, you will place it right there. So we'll reference the geometry after. Minus 4. Check geometry. Now I'll add my constraints. Just a little detail. Normally, if you were intending to build up this this foil, you will probably use a little radius at the leading edge rather than having that sharp corner in there. However, if we try to do the same task with a radius, it would just complicate things unnecessarily. But it's just a note, it's something to bear in mind. Okay, so next section, we're getting there. Yeah, it's getting a bit more exciting, only 2 more to go. What I've done, I've just used my slice graphics in order to get rid of the plane that is actually on the way now. Okay, equation curve, chord 6, enter, curve minus chord 6, enter. No. So careful here, we want to sketch on work plane 7 instead of work plane 8. So work plane 7, slice graphics. Okay, so let's paste our last equation finally. It's got there, the end. My maximum is 7. There we go. Next one, minus 7. Finish sketch. Okay, so we are done building the skeleton for our brother. I'm going to turn off all of my work planes because I don't need them visible anymore. And now I can proceed to loft our rudder. So I'm going to use the loft command. So first you have to select all of your sections. Then before we do the top, we will add our rails. Actually, I'll add my last section. And now this is the reason why I created rails. Just so my sections follow my planform sketch. So where it says select rails, this is the reason why I have my two sketches separated and not as one, because otherwise if the same rail was intersecting the same profile section twice, it will give me an error message. As you can see now, it's following that path, and now I want another one on my leading edge. Oh, what is this? This shouldn't be happening. I've just realized that after placing my rails, the surface doesn't go quite right. So I will investigate and come up with a solution for this problem. Hello guys, so I'm back here again. I figured out the issue, and in this case there was no issue. I thought that I may have done something wrong, but it doesn't look like it is actually the case. The thing is, I've never made a rudder on Inventor. However, I've done it on SolidWorks. Previously, I modeled this one 3 years ago, following exactly the same technique, and as you can see, it is really smooth. And if you check my loft, you can see my rails and how my profiles follow those rails perfectly without any strange bumps. So I found this very suspicious, so I decided to make a post on the Inventor forum. People in this forum find it quite a strange case. We have a software engineer from Autodesk, our friend Johnson. He did have a look at it, and he did try to build a model in 3 different ways. So his first go at it, he basically tried to loft this section at the top first, then this section, and then this part in between. It is a solution in a way. However, as you can see, there are still some bumps here at the top. He had a second go at it, and this time what he did, he used the sweep tool. So you know you can sweep things and use a path and a guide rail. So in this case, he chose the section at the bottom. He created a central path going through the center, and he created a guide rail going through here. This one actually seems quite good. However, because you can't use a path for the leading edge with the sweep tool, the leading edge doesn't have the original geometry of our sketch. It varies, as you can see. And he had a third go at it. He did follow the same, a very similar technique, using a sweep and stitching the surface afterwards. To be fair, the leading edge and the trailing edge seem pretty good. However, at the tip, it doesn't fully respect the original geometry, as you can see here. If I find my first sketch, does not really match it. So he did comment that he thinks that this is the best that Inventor can do with the minimum number of features. So clearly, I didn't do anything wrong. Inventor has some issues, because I didn't have any of this with SolidWorks. So Inventor should really let you loft a profile using guide rails and following the curves mostly, but it seems like the tool itself is actually quite limited when an Autodesk software engineer and mechanical engineer tells you that that's the best that the software can do. However, I had a look at his approach. I got inspired by that, and I created my own solution. So I'll be showing you what I've done. Okay, so here's my rudder. What I'm going to do, I'm going to use a loft. I'll actually close SolidWorks first because it's delaying my laptop. Okay, so I'm going to loft this section, this section, this section, this section, this section. So up to here it seems pretty accurate. It seems like, even though I haven't selected the rails, it's following the right path and I get no bumps. So it's sweeping it straight away. So that's really good. The problem is when I try to loft towards this section, this section does it relatively well. Problem is this end bit. It's not quite right, so I'll just do my loft up to here. It goes off slightly. but as a software engineer said, Inventor can't do much better than this. If you would like to improve this, the best way would be probably creating another section between your rails. So what I'm going to do next, I am going to create a 3D sketch, and I'm going to include this geometry. Now I'm going to create a spline. Make sure that you select interpolation and not control vertex. Actually, I'm going to include this geometry as well. I'm going to look at my sketch from the front. And now I'm going to use my nearest in order to follow this curve. Just at points in order to follow the curve closely. And now I'm going to click on OK. So I got my 3D sketch here. Now I am going to delete my projected geometry. Probably these two as well. Okay, and now I'm going to click on Finish Sketch. Now, the next thing I'm going to do, I am going to create a loft, but in this case, instead of doing solids, I'm going to use some surfacing techniques. So my output is going to be a surface, and it is going to go from this edge. Now it's going to go towards my 3D sketch. So I'm going to select it from my model tree. There we go. So as you can see, that line is closely lofting a surface towards the other line. And now I'm going to add my next section, which is going to be my other part. And now I'm going to click on OK. So there we go. I've got my tip as a surface. Now I need to close the surface because it is not closed up. It's just placed on top of the tip, but it has to be closed up. So I'm going to use a boundary patch. I'm going to select these two edges. So as you can see, I am creating a boundary loop that closes. Okay, I am going to first delete it should let me do it now, I believe. There we go. So now it's creating my boundary there. Now I'm going to click on apply. So now I have this surface and my bottom surface. So I'm going to stitch them together to turn them into a solid. So I'm going to click on both surfaces, my loft and my boundary patch. And now I'm going to click on done. So I have selected my loft, I have selected my boundary patch, and now I'm going to click on apply. There we go. So it has stitched those surfaces and turned them into a solid. So overall, looking at the planform sketch 1 and 2, doesn't look too bad after all. It is a shame that we couldn't use the rails as we would normally use in SolidWorks. So we have lost some accuracy. But as the Autodesk engineer said, this is roughly the best you can get with Inventor. And again, if you want to achieve more accuracy, I would just generate more sections in between. So by looking at his solution, I think we should be happy with this. So yeah, thanks for watching guys, and I'll see you in the next one.